So question 10, we have find the domain of the function. So f of x equals the square root of 3x minus 15, 3 times x minus 15. So again, this is described as the square root symbol. There used to be like this little 2 here. So the square root symbol, there used to be like this little index number of a 2, but this symbol and now is most commonly used. So on your calculator, that's what you'd be looking for, is more commonly this one over here. You can use this one as well, but that one's a little bit more harder to put into the calculator. So again, the square symbol is the inverse of squaring. So remember, when we talk about inverse thinking, that's basically what we call thinking backwards. So remember, if I gave you 6 plus 1 is equal to, say, it don't look like a 1. So let's say 6 plus 1, if that's equal to 7, inverse thinking says you can go backwards and use the inverse operation, which would be 7 minus 1, and that would get you back to the 6. So it's very powerful in algebra. So if I had some number plus 3 is equal to 10, you could think backwards to say, well, 10 take away 3 would give me that value. In other words, 7. So that's where we have what we call algebraic thinking. So in math, we have what we call squaring. So if I give you the power of 2, x squared, so if I put 3 in place of x, we have 3 squared, and 3 squared means 3 times 3, which is going to equal 9. So 3 squared is a shortcut for 3 times 3. So we have that button on our calculator. Notice with our inverse operations, they're next to each other. So notice that adding and above adding is subtraction. If you have multiplication above multiplication is division. Notice that x squared, notice how we have the square root symbol that's above it. So they're going to be connected to each other. So the square root symbol is the inverse. So if you put into your calculator 3 squared, notice that's going to give you 9. Now, if you go the other direction, so if I say 3 squared is equal to 9, what you should be able to do is say the square 9 is going to take you back to what squared gave me 9, which would be the 3. So that's why we refer to it as the square root. So root kind of means origin. What are your roots, origins? What this is saying is, what's the root number that was actually squared that gave you what we're talking about? So if I look at a table of squares, so if I use the y equals button, clear this off. If I put x squared into the calculator, if I go to the table, it'll give me my table of squares. So, for us, we could say 1 squared is 1, 2 squared would be 4, 3 squared would be 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, and then 9 squared is 81, and 10 squared is 100. Those are the most common ones we should know. So we really want those in memory. So if I gave you the square root of 4, you should recognize that the square root of 4 is, what did you square and get 4? Well, that would be a 2. Or if I ask you what's the square root of 100, what you were asking yourself is what squared, 10 squared equals 100. So what squared gave me 100 would be the 10. We're looking for the root value. So what did you actually square to get 100 is what the square root is doing. So it's going backwards. So not all numbers have perfect squares, are perfect squares. These are what we call the perfect squares, so they can actually be taken the square root rather easily. If you can't take the square root of it evenly, then we'll get into that later. So anyway, the question is, we want to find the domain of this function. So the square root symbol is now present. So the question is, another situation where a real number cannot be calculated is the square of a negative number. I should say the square root of a negative number. So if we do have this situation, we want to set what's inside the square root symbol to greater than or equal to 0 and solve for x. So notice that if I gave you the square root of -4, what this is asking is, what squared gives me a -4? Well, that's not possible. So notice that if you put a -4 into the problem, it will crash because you cannot take the square root of a -4. So if you look at your calculator as far as modes go, notice down here we have this real mode. So right now, if we're talking about domain range, we want this real mode. Sometimes we have this other mode, A plus BI, highlighted. For the time being, we want the real mode into the calculator. So if I quit that, notice how quit's in blue, second quit. If I take the square root of -4 on this calculator, notice that it gives me, you're in real mode. All calculations must result in a real number. So the square root of -4 does not result in a real number. So again, remember, our domain is the set of real numbers. So we're talking about these real values, and this does not represent a real value. So we have an issue here. So again, you cannot take the square root of an egg number. It's not going to give us a real value. So since this square root symbol is present, we are going to have some domain restrictions. So what we did is we set this 3x minus 5, I'm sorry, 3x minus 15, we set that to be greater than or equal to 0, because what's inside the radical cannot kick out a negative value. So if we add 15 to both sides, we get 3x is greater than or equal to 15. If we divide both sides by 3, and we're going to get then this x is greater than or equal to 5. So if we think about this, if you pick 5, notice that 3 times 5 minus 15 is going to give me 0. So if you pick a number greater than 5, it should create what we call a positive value. In other words, it's going to be greater than 0. So if you pick like 6, 3 times 6 minus 15, notice that gives me a 3. And we can take the square root of 3. It would just be a decimal value. So if I took the square root of 3, it's going to give me some type of decimal. So sometimes we'll have to rely on the calculator to get our decimal answers. Back in my day, we used tables. But notice that if you pick a number that's not greater than or equal to 5, in other words, if I pick, say, 4, if you put 4 in for x, 3 times 4 minus 15, notice how it's going to give me a -3. So it's going to crash. So what we're saying is, to our original problem, if I put a number less than 5 into this problem, it's not going to result in a range value or a y value. So again, if we use interval notation for this, we're going to be saying that, let's see if we want interval notation here, it doesn't say. So if I'm using interval notation, we would be saying our domain is, so if I use a number line to kind of visualize this, let's see here. So if I have 5 here on the number line, we can equal 5 and we can be to the right of 5. That's our domain. We can't not be over here left of 5. So notice how there is a left bound, which is a 5. So actually I need a bracket there. So I need to include the 5. That's a bracket. And then our right bound is infinity. So infinity, and it's open-ended, so it's a parenthesis. So that would be our interval notation for that. That would be our domain, is from 5 to infinity.